Hello everyone, this is Dr. Mocha. Today we have the lesson for pre-IG, physical quantities and measurements. The content we need to cover is we need to describe the use of rulers in measuring cylinders to find length or volume. We need to know how to measure a variety of time intervals using clocks and digital timers, and determine an average value for a small distance and short interval of time by measuring multiples. Let's start with the measurements. We need to be able to measure time using seconds, length in centimeters or meters, and volume in milliliters or centimeter cube. Let's start by measuring time. When we're asked to measure time, we'll always be asked to do it in seconds. So we need to be able to convert minutes to seconds or hours to seconds. Let's look at the example we have here. First of all, we have here the minutes, the seconds, and the 1/100 seconds. So for these two, we're just going to leave them as they are, 22.10 seconds. What about the minutes? How do we convert minutes to seconds? We multiply it by 60. So it's 1 minute, so that's 1 times 60, so that's 60 seconds. So in total, what do? We have to actually take the time we have, which is 1 times 60, as we can see in the start time, plus 22.10. So this gives us 82.1 seconds. Okay, this was the time at the start. What about the time at the end? Same thing. We'll take the 46.5 as it is, and we're going to convert the minutes to seconds. So 3 times 60. So as you can see how it's done, 3 times 60 plus 46.5, we got 226.5 seconds. Now the question is asking us to get the time that was taken from the start till the end. So obviously we're going to do the end time, which is 226.5, minus the starting time, which is 82.1. Now, since we got them both in seconds, so my final answer, 144.4, has to be in seconds. So the first thing I need to know when we're measuring time using a stopwatch is I have to make sure that my time is calculated in seconds before I find the difference between the start and the end. Let's try this one out. This is an example from the past papers, and it's asking a digital stop clock measures time in minutes and seconds. It reads 00.50 in the start and 2.10 when it stopped. So what do I need to do? I have them in minutes and seconds in the start, minutes and seconds in the end. They're saying what's the shortest possible time that has passed between the starting and stopping for the stop clock. Okay, and they want me to get it in minutes and seconds. That's fine. So I have 2 minutes and 10 seconds and 0 minutes and 50 seconds. So what I'm going to do is I'm going to subtract. First, and the easiest way, is to convert them all to seconds. So what I understand is that my starting time was already 50 seconds. And my stopping time was 2 minutes, so I'll convert this to seconds, and 10 seconds, which is equal to 130 seconds. So the difference between 130, we said we'll always do with the end minus the start. So 130 minus 50 is equal to how many? It's equal to 80 seconds. And if we translate 80 seconds, that's equal to what? 1 minute and 20 seconds. So my answer is going to be B. Okay, moving on. Another way to measure time is using a pendulum. The pendulum is having a wire connected to a bulb, like a small ball. And that ball or the sphere goes from one side to the other. Now, here we need to know a couple of things. First of all, we need to know the sphere's name, which is the bulb. Second of all, how does it perform one full oscillation, one period of oscillation? I have to know that a full oscillation is from the starting point all the way to the end and back. So I have to return to the starting point to have a full oscillation. So if I'm starting at A, I have to go all the way to the end and back, and that's one oscillation. Okay, what if I started here? Then it has to go all the way here, all the way back, and all the way here to the starting point. That's one oscillation. Okay? So if the time is too small, a pendulum can go really, really fast. How will I know how many seconds it took for the oscillations? I'll take a couple of oscillations. Let's, for example, say 10 oscillations. And then what I'm going to do is I will take the time it took for those 10 oscillations. Let's say it took 30 seconds to do the 10 oscillations. And then I'll divide the total time by the number of oscillations. Now, I want to give you a heads up. If I'm trying to calculate the time, then what do I put up? The number of oscillations or the time? It's always the thing that I'm calculating. Since I'm calculating the time, so I'm going to put the time up and the number of oscillations down. So that's going to be 30 over 10. So this tells me that it takes 3 seconds per oscillation. Okay? All right. Let's take an example. A student measures the time for 20 oscillations of a pendulum and records it as 40.2 seconds. Calculate the period for one oscillation. Period means time. So again, we're going to put the time up and the oscillations down. So what do I need to do? I need to put the time up, which is 40.2, and the oscillations down, which is 20. So just one way to reduce the percentage uncertainty in this measurement. How will I make sure that my answer or my value is correct? First of all, for the first part, of course, as we did, 40.2 over 20, the answer is 2.01. And since we're measuring time, the unit is always seconds. And the way to reduce the percentage uncertainty in this measurement is that maybe I can take 50 oscillations instead of 20, 60. The more the oscillations, the more accurate your answers are. Another example, a student sets up a pendulum but notices an inconsistent timing results. Identify 2 possible sources of error in this setup and suggest improvements to reduce these errors. Sources of error could be a lot. It could, for example, be that the reaction time means the time a person or human reacts to start the stopwatch or stop the stopwatch or pay attention to where the pendulum stopped or started. So this is all called reaction time, how you're reacting to something. So reaction time when starting or stopping the stopwatch. Maybe the pendulum is going around, not just left and right. So maybe it's not going in a single plane. Maybe the large amplitude, how it's going all the way up, I am not controlling how far it's going, so it's affecting the time. Okay, what can I do to improve that? I can use a fiducial marker. Fiducial marker tells me where exactly to mark the starting or ending point of the pendulum. I can take more oscillations, and I can use an electronic timing or video analysis to know exactly how long it took, start to end. Here's a third example. Diagram shows a pendulum that oscillates between P and Q. This is P, and here's my Q. Which method is used to find the average period of oscillation for the pendulum? So, as we said, how can I get the period of oscillation? A, measure the time it takes to swing from P to Q. Measure the time it takes to swing from P to Q and back to P 10 times and divide that time by 10. Measure the time it takes to swing from P to Q and back to P 10 times and multiply that time by 10. Measure the time it takes to swing from Q to P. First thing we need to know is, remember, we said An oscillation is when it goes from a starting point all the way to the end and back. So if I'm starting at P, then I need to go all the way to Q and back. So this gives me two possibilities, either B or C. Second thing, if I'm taking this oscillation or that amount of going and coming 10 times, do I divide or multiply? As we've agreed, we divide. So I've taken this oscillation 10 times, so I need to get the accurate value by dividing by 10. So the correct answer will be B. Moving on, length. To measure the length, we usually use it in centimeters. So therefore, what I'm going to use is a ruler. Okay, what if I asked you to measure the length or the thickness of a tiny paper? Can you measure the thickness of a paper? It's very, very small. It's very hard to do. So what's the easiest way to measure small lengths like thickness of a paper? I will take a couple of papers of the same type, maybe let's say 200 papers, 200 sheets of papers, and I'll measure their thickness, and then I'll divide. Let's say that the value I got here was 20 centimeter. Do I divide 20 by 200 or 200 by 20? Remember, I'm asking you about the thickness. So obviously, we said when we divide, I put the thing that I asked for on top. I asked for the thickness, then we will put the thickness on top, 20 centimeter, divided by the number of sheets. Okay? So accordingly, I'll get my answer, and my answer has to be in centimeters. Let's take an example. If we're, for example, looking at, here we go. The figure below shows a closed textbook. There are 270 sheets. When you're reading a question, always mark the numbers and the values because it will make it easier for you to put it in your equation. Of paper in the textbook, the total thickness of the sheets is 29 millimeters. Calculate the average thickness of one sheet of paper. What am I calculating? The thickness. So I'm going to put the thickness up and the number of sheets down. So the thickness is 29 millimeters and the number of sheets is 270 sheets. When I get the answer, do I put it in millimeter or centimeter? Let's look at the value. It's in millimeter, so I have to put it in millimeter. It's as easy as that. So the answer, I'm going to put 29 over 270, which is 0.11 millimeter. If you were asked how to get a more accurate value, then maybe I'll add more sheets or more books. Another example, a student uses a meter ruler to measure the length of 6 identical table tennis balls placed between 2 wooden blocks. What's the diameter of one ball? A common mistake here is that students simply just go like, okay, so they want us to start from the starting point to the end point. I'll just subtract, so that's 62 minus 38, which is going to be equal to 24. So the answer is 24 centimeter. Is that right? No. Why not? Because they told you they have 6 of those tennis balls. So what do I need to do? I'll divide this by 6. So what's the diameter of one ball? The answer is going to be 4 centimeters. All right. Next, we have measuring volume. When we want to measure volume, we have 3 kinds of things we can measure. For example, I can ask you to find the volume of a rectangular block. This is easy. I'll just use my equation. The volume for a rectangular block, as you've taken in math, is length times width times height, and my answer is always in centimeter cube. So let's say my length is 3 centimeters. My width is 1 centimeter, and my height is 2 centimeters. So my volume will be 3 times 1 times 2, and my answer is going to be 6 centimeter cube. Of course, remember that the volume for each regular shape is different. The equation is different, which we're going to cover in a later lesson. What if I give you an irregularly shaped solid, such as, for example, a sharpener or a toy? How will you find the volume of that? It's very simple. I'll get a measuring cylinder. Do I need a ruler now? No, I do not need a ruler. I'll get a measuring cylinder. I'll put some water in it, but I have to know exactly where I stopped. So I'm going to add some water, measure the water. For example, here I have 50 milliliters, which is the same as 50 centimeter cube. And then I'll add the toy or the sphere or whatever object I have that has an irregular shape. Of course, when you add it into the water, what's going to happen to the water? It's going to go up. So then I have the final reading. So as per this, my final reading is 65 milliliter, which is the same as 65 centimeter cube. So what do I do next? How much is the volume of my sphere or my toy or the object that I added? I'll just subtract 65 minus 50, which is going to be 15 centimeter cube. Finally, liquid, which is the easiest one. To measure the volume of a liquid, I also will use a measuring cylinder and I'll add my liquid to it. Now you have to be very, very careful. When I'm reading, I should not look from up nor from down. I should always read at eye level to avoid parallax error. What's parallax error? When you're reading from a corner or from a side, you tend to see the number a little bit less or more than the actual reading. So you have to read at eye level to avoid parallax error. Let's take an example. A student is asked to find the volume of a small, irregularly shaped piece of rock. They have a balance, a measuring cylinder containing water, and a ruler. Now, irregular shape. Remember we said an irregular shape, we do not need a ruler. So what do I need? Do I need a balance? Am I measuring the mass? I am not measuring the mass. I only need the measuring cylinder, where I need to know the starting point, and then I'll add my object, get the final point, and then I'll subtract. So therefore, what's the correct answer? Measuring cylinder only. All right, moving on. Here's another example. A student has 6 100-gram masses, and they have a measuring cylinder and a beaker containing water. The student uses the equipment to determine the total volume of the 6 masses. Describe a method that the student uses. So what do you think we should do to get the volume of the 6 masses all together? I'll add the water into the measuring cylinder, take the start measurement, add my 6 masses, and then I'll get the final measurement and subtract. Let's see what the answer says. So, measuring cylinder filled with water, get the volume of the water recorded. Don't skip this step. You have to know the volume of the water before you add your object. And then I'll add the mass into the water and get the new volume recorded. And finally, I must get the difference between them. This question is usually 3 marks, so you have to write 2 of the initial steps and you have to write that you're going to get the difference between them to get the full mark. Another example, a student measures the volume of 3 liquids using 3 different measuring cylinders. The table shows the volumes recorded by the student for cylinder 1, 2, and 3. Which readings are correctly recorded? Why is this important? Because in some measuring cylinders, you're going to find the difference or the values that are stated, as you can see in 1 and 2. In one, each 5 dashes is resulting in 0.5, which means that each dash is equal to what? Is equal to 0.1. In number 2, each 5 dashes result in 1.0. So I have to divide the 1.0 divided by 5 to know how much each dash costs, or how much each dash is equal to. So each dash is going to be equal to 0.2. So you need to be very careful when reading the volume from a measuring cylinder to know how each dash is equal to, how much is it equal to. So for the first one, let's read. If I know that each dash is 0.1, let's look at our liquid. After 1.0, there's a dash, so that's 1.1, and another dash, so that's 1.2. Okay? Second beaker. Each dash is 0.2. I stopped at 2, so one dash, that's 2.2. One dash, that's 2.4. Let's look at the third beaker. 5 dashes give me 10, which means that each dash is with 2. Now let's look at where the water stopped. It stopped at, we have the 20, and then one dash, that's 22, one dash, that's 24, and it stopped halfway through that, so that is 25. Now let's look at our answers. Number 1 was 1.2, that's correct. Number 2 is 2.2, nope, it's 2.4. Number 3 is 25, that's correct. So my answer should be 1 and 3 only. That's all for today. All the best of luck. See you in the next lesson.